All right. So, just for public consumption, Clark, that is going to be my fidget spinner. You've turned it into a toy. This is being recorded for posterity's sake.
It's always been a toy.
All right. So, for the first problem, we're going to start with problem number 2. And we are going to solve this problem. Now, I'm looking at this, and I notice that we have a square binomial right here. And so I am going to factor that as a square binomial. Now, I am not writing this for my health, Missy. I am writing this so that you can get these notes down.
I already know that x plus 3.
So I know that this quadratic expression will be factored as x plus 3 squared is equal to 16. Well, to extricate the x from the parentheses, and especially since that term is being squared, I need to
Square root both sides.
Square root both sides. Thank you, Brody. So let's square root both sides. The square root of the quantity x plus 3 squared is?
X plus 3.
Bless you. The square root of 16 is?
4. Plus or minus 4. Plus or minus 4.
Plus or minus 4. So then, let's subtract 3 from both sides of the equal sign, and I get x is equal to negative 3 plus or minus 4. Now, we are not going to have a irrational answer here. So let's go ahead and give us the simplified answer. Negative 3 plus 4 is 1. And x also equals?
Negative 7.
That was nice. Harmonized is really, really wonderful. So we would end up putting both answers in our blanks. Okay.
Eureka, I have found it. Dorito, I have found it.
Problem number 6. Problem number 6, we are asked to solve using the process of completing the square. So we are going to complete the square. So we know that we have 5x squared minus 20x plus something, because I'm completing the square, is all equal to 10. Well, in the completing the square process, we need to have a quadratic term that is a perfect square. And 5 is not a perfect square. So we are going to divide everything by 5 so that we have a perfect square term for our quadratic term. So divide by 5, divide by 5, divide by 5. The battle for getting the answers first at the front table is fierce. Pull no punches.
Dominating this competition.
So we have x squared minus 4x plus something, I don't know what that something could be, is equal to 2. And notice I've just divided all of the coefficients by 5. Now, to find the number that I'm going to add, I am going to have to take the coefficient of the linear term, divide it by 2, and square it. So if I add 4 to this, to the left side, I must add 4 to the right side as well, which will leave me with x minus 2 squared is equal to 6. Hey, Selma. Selma, what did I do to go from x squared minus 4x plus 4 to x minus 2 squared, the quantity x minus 2 squared? What did I do? I factored it. That's exactly what we did there. All right. So in order to get the x out of the parentheses and out of that pesky squared, what we'll have to do to both sides? Mr. Potter.
Wouldn't it what it is.
What's the opposite of squaring?
Square rooting.
We're going to square root.
Yeah, obviously. I knew what the answer was. What?
All right, so we take the square root of both sides. And Tyler, you will not be surprised to find that for the left side of the equation, what will I get?
X minus 2.
X minus 2. All right, and I don't need the parentheses anymore. And I'm just left with plus or minus the square root of 6 on the right. So, Reese, what do I do next?
Find the square, or no, you add 2.
Let's add 2 to both sides. So we get x is equal to 2 plus or minus the square root of 6. So at this point, we have our irrational answer, because the square root of 6 cannot be simplified further. So it is fair for me to go ahead and say 2 plus or minus the square root of 6 up here. But we also need the decimal equivalent. So I'm going to pull out my calculator. I'm going to find the squirt of 6, also known as the square root. And let's do 2 plus the square root of 6. So I'm going to add 2 to the square root of 6. And so I get 4.45, because you were asked to round to the nearest hundredth. Then I'm going to take the square root of 6 again. This time I need the negative variety. And I'm going to add 2 to it. And I will get negative 0.45. And so here is my solution set.
Eureka, I have found it. Eureka, I have found it.
Eureka, I might have found it.
Moving on to the quadratic formula. For problem 10, you are asked to solve using the quadratic formula. And the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So, if I'm looking at this term right now, I notice that it is not equal to 0. We need this to be 0. So what will I do to both sides to get this equal to 0? Oh, I don't know. How about max? Let's add 7 to both sides. And when I add 7 to both sides, I get 4x squared minus 12x.
Is that supposed to be in X?
Yeah, I think so. Plus 7 is equal to 0. Otherwise, it's linear. All right. And so we know 4 is my a value, negative 12 is my b value, 7 is my c value, and it's beginning to look a bit like Christmas. So, negative b we can wait for you to regain your composure. So we have negative or minus negative 12 plus or minus the square root, and b again is negative 12 squared. That almost looks like a negative 12 if you really squint and believe hard.
Just like Santa.
Just like Santa Claus. Minus 4. My a value is 4. My c value is 7. And that is all over 2 times 4. So the opposite of negative 12 is positive 12. So we get 12 plus or minus the square root Negative 12 squared is 144, thank you. Minus 112. All over 8. 144 minus 112 is?
No, 32.
32. So we get 12, I wish it was 36, plus or minus the square root of 32 all over 8. Now, the square root of 32 contains a perfect square factor. What number goes into 32 that's a perfect square factor? Oh, I don't know. How about Rashid? 4 does go into 36, but I think there's a larger perfect square number that goes into 36.
32.
16. So the square root...
I'm saying like, you're saying 36. I was saying.
We're still stuck on 36 up front. All right, so the square root of 32 can be written as the square root of 16 times the square root of 2. The square root of 16 is 4, so we have 4 root 2. So I'm going to erase the square root of 32 to save some room, and I'm going to say 4 times the square root of 2. But wait a second. Is there a number that goes into 8, 12, and 4?
4.
4 goes into all of them. So we have 3 plus or minus, because 12 divided by 4 is 3. The square root of 2, because 4 divided by 4 is 1, all over 2. And so that will be our simplest radical form answer. So I'm going to put that on the answer blank. Now for the decimal equivalent, I will pull up my calculator. I will find the squirt of 2. And I'm going to add it to 3. Because 3 plus the square root of 2. And then I'm going to divide it by 2. I get 2.21. And so I will again take the square root of 2. This time it's negative because I'm doing 3 minus the square root of 2. So I combine it with positive 3, divide by 2, and I will get 0.79. And there we go. Yeah, I know, I'm having a blast. This is like the best day ever. Lauren, would you mind joining us up front?
Hey.
We need you to match wits with these guys. Okay, Cooper is excited. Okay, the last problem we'll go over. We are to find the discriminant and the number of roots for number 14. No, right here is perfect.
She's got the hot seat.
All right. So the discriminant is described as b squared minus 4ac. My a value is the coefficient for the quadratic term. My b value is the coefficient for my linear term. And my c value is the constant. So we have a b value of negative 3. So we have negative 3 squared minus 4 times 1 times 9. So negative 3 squared is? It's not 6, it's 9. See, if I write, see if I can get you to say 6. And then you feel a little bit foolish. So then we have negative 4 times 1 times 9.
Negative 36.
That is negative 36. 9 minus 36 is? Negative 27. If we have a negative discriminant, that will give us, River? Zero real roots.
Yay!
Okay.
That was a fun time.